Well, thank you very much for inviting me. I wanted to talk today about some tools that we've used for a long time at the University of Wisconsin in Madison to reveal what we've been calling the invisible place and the invisible present. We're very much absorbed in the present right today and where we are. And in the early 1980s, we received a grant from the U.S. National Science Foundation in a program called Long-Term Ecological Research Program. And scientists at that time were frustrated by most grants they received were 3 years. And how could you study phenomena that are slow? So what I'm going to do today is give you an example of some of the research we've done under this program starting in 1980. We argued that the program was essential to reveal the invisible present and the invisible place, not visible in short-term studies. It's like a microscope or any other tool that scientists use, but this expanding of the time and space scales was important. Not visible in short-term studies of small plots. This tool is also useful in outreach to explain changes that occur slowly, like climate change. And my talk today is a talk that I gave at the Addicts Angel community in Madison. And it's a group of people, very energetic group of people with good staff. And I'm going to talk about lake ice and loss of winter as we knew it and what is happening. This is a kind of a study that I could talk about to your group that could not have been done if we didn't have the long-term aspect to the data. First, how do we deal with change? The canoe paddler in the lower right, a small sailboat, and get off the lake in the upper right. We know how to respond to these things, or a storm. The university even has a rescue boat that goes out and picks up people who didn't do a good job of that. Well, changes actually occur rapidly, like a thunderstorm. They occur between day and night. We know what to do, when to get up, when to go to bed. Some of you have to work at night. But anyhow, we've accommodated to day and night pretty well. We also accommodate the seasons. You're quite familiar with when to get the hunting rifles out, when to go ice fishing, and when to fish for the walleye. So we know how to do seasons. We're pretty good at that. But when things get slower and don't repeat at frequent intervals, we have trouble dealing with information. For example, land use. It sort of sneaks up on you, but before you know it, you're no longer in the suburbs, you're in the middle of town. Eutrophication, which is a scientific word for the oversupply of nutrients to a lake, like when you farm or rake your leaves into the street and so forth, they get in the lake. And climate change. And climate change is the slowest thing. And I'm going to be talking about climate change. Well, people have been thinking about these. They're not brand new ideas. People have been thinking about this. Marcus Aurelius Antonius was a Roman emperor and a philosopher. And he wrote that time is sort of a river of passing events, and strong is its current. No sooner is a thing brought into sight that is swept by, and another takes its place, and it too will be swept away. Well, one of the things, if you're going to do long-term research, you need to do one thing that Aurelius didn't do. You need to make a record of each year and not lose the information. And I've tended to refer to this as the invisible present. If we don't have these long-term kind of studies, the present is really invisible to you because it's swept away. And my memory's not so good anymore. It gets swept away farther. Okay, anybody know what clock that is?
Is it Big Ben?
It's Big Ben. And it's at 2:45 in the morning. So that picture is an invisible present, 2:45 on whatever night that was, and in downtown London. Well, Lake Mendota Ice On Day, this is one of the very longest days we had. That the ice on occurred in January 20th in 2007. And what I want to do is talk about the invisible present using the ice data. Now, when I first moved here, which was about 45 years ago, we'd go ice fishing between Christmas and New Year's. Well, not on this year. So here's a way of looking at the invisible present using the ice data. And there you see a red spot. And think of this curtain that's next to me being pulled to the left and revealing longer and longer time scales. And that was less than a month. If we open it up to 10 years, you learn something else. That was a really unusual year. And in fact, it was less than a month. And the year before and the year after was pretty close to 3 or 4 months. Let's keep opening it up. What else do we see? Well, if we open it up to 50 years, we still see that was an unusual year. And in fact, if you were doing your master's thesis or writing a book and you were depending on looking at the ice on Lake Mendota, you wouldn't want that year in the time series. It just wouldn't work. It also looks like the amount of ice days are decreasing a bit. Let's open it up to the full scale. Fortunately, and one reason we picked these data to talk about the invisible present is the people in Madison started recording the ice on and ice off dates on Mendota in the 1850s. And what you can see now is you fit a straight line to those data. There is not only a lot of variability, but you also see that the trend is changing. If we do the statistics on it, you almost don't need to do the statistic on it, but the duration of ice on Lake Mendota has declined. Another thing that's happened, here I've done a really simple thing. I've taken the 10 longest ice durations and the 10 shortest. The 10 longest are the blue dots in the upper left. The 10 longest are the red dots, mostly in the lower right. And what you will note that all the really long durations are before 1900. It's not quite that clear with the ice off date, the ice on dates, but you can see they're clustered toward the right. But still, that year that we first looked at is the shortest duration so far. Well, let's talk a bit about the invisible place. It's clear that if you want to make some generalizations about climate change and what's happening to ice on Lake Geneva in Switzerland or Lake Geneva in Wisconsin, you need to not confine yourself to a single lake. And people have been thinking about this for a long time too. I really like Emerson's quote. He lived in New England. He was a philosopher. And basically the quote that is captured and quoted the most is, "A field cannot be well seen from within the field." Well, we look in the field a lot, but if you look in the field and you're in the field, you don't see how this compares with another lake, another continent. I liked Al Gore's comment too. It's helpful to stand some distance from anything you're trying to see a pattern and are trying to comprehend. And John Hayward is the winner here. You're all familiar with this quote: "Not being able to see the forest for the trees, you cannot see the wood for the trees." And this idea is that, again, that people are most likely to think of the forest they're in or the forest outside their garden. And that doesn't tell you about the invisible place. It doesn't. So we're going to be talking about the invisible present and the invisible place. Let's start out with a few of Wisconsin's lakes. We have thousands of lakes, but here are 46 lakes with a fair amount of observation on them. Lake Superior has a long record because of the ferry that goes out to Madeline Island. And how do they get out there in the wintertime? In the lower right, you've got our Lake Geneva, and the farther south than a fairly deep lake. And you see a lot of lakes near Madison and elsewhere. If you look at all these lakes, then just take the line. Forget about all the year-to-year variability. And you'll see that every one of these lakes that we have long-term records on are all having declining. So this isn't unique to Lake Mendota. One might wonder, why is Shell Lake, which is up in the northwestern part of the state, almost flat? I'm not sure I've got that answer for you. If we take two of the lakes, that Shell Lake, which is changing very slow, that's the red on top, and the Lake Superior record at Bayfield. And the way that record was kept was an early explorer and liver, someone who lived in Bayfield would record the first date that a new boat arrived in the harbor and the last date that the last boat got out of the harbor. And he noticed that, well, he didn't record ice, but that's why they could get in or not get in once the ice was there. And if you look at the right-hand side of the record for that ferry out to Madeline Island, you see that we're beginning to see years where the ferry is able to run all winter long. Well, the early sailboats were wooden hulled. The ferry boats that are there now have ability to break ice, and they can break ice up to about 6 inches. And so this is not just a pure record of ice, it really is when the boats arrived and came. Well, I gave this talk in Madison, and this particular graph is a model in the projected decrease in extreme cold days, less than 0 Fahrenheit. And you'll notice the star is Madison. And if you look at the green, we expect that from between 61 and 2000 to the 2046 to 65, we're expecting the number of days in Madison. It's a model. It's based on good science, but it's not an observation. Would be probably around 15 days, maybe a little less. All right. So with that, you might suggest that if you were going to try to project the future, if this model is correct, the amount of ice forming would change. Okay, well, that's Wisconsin. We also managed to talk the National Science Foundation into gathering with some of our European friends. They, believe it or not, have also been measuring the duration of ice on lakes in Europe. And here we have a little more complex graph. The ones at the bottom that are going up are the date of freeze. That means that the date of freeze is less and less and less. It's freezing later and later. If you look at the same group of lakes in the upper part, I think there may be even a river in there that's going down. And so the duration of ice is between the upper lines and the lower lines. And so I can't use sign signals, but I think what you see is the same phenomenon that's going in Mendota and then the Wisconsin lakes is also occurring in Europe. other places. So this is removing the idea of the invisible place. If I just showed you the Mendota data, we could come up with all sorts of ideas, and lots of you have asked questions in the past of me. Well, that's got to be something local that's causing Mendota. Maybe all the nutrients that are coming in, or some other thing like that. But it's happening in all these lakes. And if you look really closely, look at the jig-jags. Look at some of these in the upper right, and you'll notice that the zigs and the zags, the highs and the lows, even seem to be following each other. So some of the variability around these lines is caused by things that are occurring not only in Wisconsin, but are also occurring in your Baikal, Lake Sewell, so forth. Well, let's talk a little bit about climate science. If you've checked at all about what's causing the warming, current beliefs and knowledge points to CO2, and because it tends to act as a sort of greenhouse and reflect the heat back to the earth. And the first person who knew this, my name Magnuson. I'm really proud of this guy. It was Svante Arrhenius, a Swedish chemist. Notice he doesn't have a Swedish name like Magnuson. The intellectuals in Sweden and a lot of Europe would change their name to a Greek or a Roman name. But anyway, he was Arrhenius. He was a chemist. And this was done in 1896. I wasn't born yet. None of you were born yet. And here's a direct quote. If the carbon dioxide is increased 2.5 to 3 times its present values, the temperature of the Arctic regions must rise 8 or 9 centigrade. That would be somewhere between 15 and 20 degrees Fahrenheit in the Arctic, and produce a climate as mild as that of the Eocene. I'm not a good geologist. When was the Eocene? How many million years ago? But anyway, good for him. This is not something we just dreamt up last year. Another advance in the greenhouse gas thing was by this particular scientist, Charles Kennedy, and he said, well, you know, we should be tracking, we should have long-term data on the CO2 in the atmosphere, the same as we have long-term data on the ice cover on Lake Mendota and many other lakes. And so he set on the top of Mauna Loa, I think it was, trying to think, there's 2 islands out there, whether it was Mauna Kea. No, it was on Mauna Loa. And he measured the greenhouse gases on the top of an island in the middle of the Pacific, no industries nearby, and high altitude, 13,000, 14,000 feet or something. And you'll notice, as clear as the ice stream on Mendota, the greenhouse gases are going up. Now, you might wonder about the jiggles. The jiggles in this case are very regular. They're not sort of all over the place. And that's seasonality. Seasonality of plant growth and release of carbon dioxide and respiration in the wintertime and so forth and so on. So scientists in other fields have also figured out ways to make measurements over a long time, which helps them. One of the things that scared me about this graph was one of my colleagues in the atmospheric sciences pointed out that the top of this graph, it was a few years ago, was 410 parts per million. And what he would tell an audience that he was talking to was, you will never see a level of carbon dioxide in the atmosphere lower than that in your lifetime, nor likely of your children's lifetime. Kind of scary. Okay, well, scientists have gotten together around the world and through the United Nations have gathered scientists from the countries around the world to gather what's known about climate change. And these things were called the, well, what was it called? The physical science basis of, well, my memory's not too good, but we'll come across the name of this. Pardon?
Is the
IPCC,
Yeah.
Intergovernmental Panel on Climate Change, you got it. And they meet and write this monograph every year, big volumes, and try to summarize all that we've learned about climate change and before 7 years ago, but up till about 7 years ago. And there it is, Intergovernmental Panel on Climate Change. And this was recognized, and they got the Nobel Peace Prize for it, for finding this out. What year was this? Do you see a year on that?
2007, I think.
Yeah, 2007. And they were delighted. Now, it turns out that I was on this program and I helped them write 2 fields. And I was writing about the impacts on lakes and lake ice and stuff like that. So they not only included the atmosphere and the drivers of climate change, but also what the impacts were and how they've been changing. Now, there was one other person that got the Nobel Prize for climate change stuff, and that was Al Gore. And so Al Gore got half of the prize, right? And how many people worked on the IPCC? About 2,000. And so I figure I also got the Nobel Peace Prize. But if you say Gore got half and IPCC got half, well, that's 1,000. And if there's 2,000 people that helped put the IPCC thing together, you divide 1,000 by 1,000, and I got 1/1000th of the award. Anyway, I was pleased to be a part of it. Now, right now, if you look at the Earth, that may look kind of unusual because it's a view that you don't normally see in a map. This is a view from generated with the map and some characteristics of where lake ice occurs. And it is from above the pole, and you can see Lake Michigan on the lower left, or not just on the left, and you see some orange stuff. And that's the limit to the north that in the current condition was about 2 years ago, that lakes froze. So everything north of that, and same thing in Eurasia, everything north of that, the lakes froze every winter. All right. Now, what I want to do is show you what happens to the range at which lakes do not freeze if you added so much greenhouse gas to the atmosphere. And we'll just sequentially add Limnology, run our model again, and take another look. Well, here I just grabbed the Great Lakes area. And so here's current. The lakes are freezing up to about the Madison area. If we increase warming by 2 degrees centigrade for the global temperatures, then the lakes would not freeze up to about Green Bay. And if you raise it, and by the way, the 2 degrees is the one that we now seem to be aiming at a policy level, that if we can keep the warming less than 2 degrees, the damages will be ones that we can live with. Well, let's don't do anything. Let's say we don't start switching away from a carbon economy and start using other things like solar and wind and Earth's temperature. Don't do anything. Then we'd expect that we'd have about 4.5 degrees centigrade warming. And at that point, all of Wisconsin would be beginning to have lakes that are, in some years, don't freeze. And then if we go crazy, one hopes we never make policy decisions that result in the earth warming by 8 degrees globally. But if we did, and I hope we do not, note that not only are all the lakes in Wisconsin ones that don't always freeze, but it goes well up into Ontario and Manitoba. Now, these are models. They're done by thoughtful people that know how to do these sorts of things. But they didn't do this with this end case in mind. They actually said, well, what do we do? What do we see if we warm the earth 2 degrees, 4.5 degrees, 8 degrees? Anyway. Well, I want to talk a little about lake ice. In many ways, most of the stuff you hear about ice is about the Arctic Ocean ice sheet and the glaciers on Greenland and Antarctica. But lake ice is a very effective miner's canary for climate change. First of all, these lakes are not off somewhere in the distance. They're right here. We're on 1, 2, 3, 4, 5 lakes here in Madison. And we have another research station in the Lake District in northern Wisconsin with hundreds of lakes in it. We have lots of lakes and people recreate on them. They do things on them. And so our lakes are not distant. We're embedded. Our cities are embedded. Our farmland is embedded. Our forest lands are. Another point I'd like to make is I think that lake ice is sort of an undervalued natural resource, but it's sort of our sense of place as a northern tier country. And you see the ice fishers and the people learning how to play hockey with their little kids and all sorts of things that we do on the ice. How many of you ice skated when you were a kid? How many of you skied at Cascade Mountain when you were a kid? How many of you played on a hockey team or went ice fishing? Well, we wrote a paper, a bunch of us got together, and Noel, who's the scientist up at Itasca Biological Station, University of Minnesota, wrote a paper in which we talked about services to us as the ice declines. And if you look at these, I'm going to move around so I can read the graph. The upper left is ice roads. And many of the towns that have First Nations people at them and halfway up Ontario or Manitoba, they ship goods back and forth with ice roads. There's no road to get to them. And the ice roads are a lot cheaper to haul out the lumber or bring in longer term supplies. Some of the ice roads are getting less safe. Outdoor skating. That happens to be a very traditional skating area around Stockholm. They could skate on it. And in the last few years, they have not been able to have that contest. One of the sets of data that I enjoy the most is the Shinto religion one and a Catholic religion one down here. The Catholic one is here in Europe, and the Shinto one is over here. But for some reason, they started keeping track of the ice on the Bodensee, or which we now call Lake Constance, and Lake Suwa in Japan. And in the last, for thousands of years, or hundreds of years, the ice in some of these places would be recorded. Now, in Suwa, I'll show you a little bit more about that later, but in the last 10 years, Suwa has not frozen more than half of the years. And if you were looking in the 1500s, 1600s, it would freeze well every year. They would land planes on it. They would practice long-term or speed skating to participate in the Olympics and so forth. This was an interesting one. what would happen here is, the Bodensee is a glacial lake that extends down from the glaciers, and it's very long. And there were Germany's on one side, France and Swiss are on other sides, and they had a custom between two of the churches, one side and the other. And if it was safe to walk across the lake with one of the apostles, they would move that to the other church on the other side of the lake and say, thanks. And then the next time the lake was safe enough to walk across, they come back to the first church. The last year that it has been safe to walk across to move the statue was in 1960. So it basically doesn't freeze anymore. Well, there are lots of things, and ice fishing. Now I want to talk a bit about Apostle Island and Madeline Island. One of our audiences from Madeline Island, and his name Madeline. And so we'll go to the Apostle Island natural seashore, and it's a lovely place. And in the upper right-hand corner, you see the ice caves that form in the wintertime as the groundwater seeps out of this layers of sedimentary rock and starts to drip and then freeze, and you get sort of stalactites and stalagmites of ice. Beautiful. But I also want to talk about what did they do when the lake froze. And the way they did that is that they made an ice road. They would go across the ice road. And if they stayed out or kept driving across longer, they started to have problems. But it goes from Bayfield to Madeline Island. And it has a lot of warm feelings for them, and it does a cheaper way of getting across than putting your car on the ferry. Well, here's a recent picture of one of the ferries, and it's an icebreaker. And as I mentioned before, it can break about 6 inches of ice. And so the years when the icebreaker can get across has been influenced not only by climate change, but also by the different design of vessels today and sailboats that were traveling Superior 100 years ago. So here's the data again. There's still ice on the lake, but less than 6 inches the ferry get across. Well, winter is part of our sense of place. If you talk to a sociologist, a lot of us have moved back closer to where we were born during our lives. And winter is part of my sense of place. And these are two comical things which are not that comical when you get right down to it as soon as I show you the next couple of slides. People are now beginning to worry about the safety of ice where people used to play on the lakes or walk across the lake or do all sorts of things. And this is a combined data on drownings that occurred for people of different ages falling through the ice. And the axis across the bottom is the temperatures in December to March. And you'll notice that over here, when you get to Estonia and a few countries in Northern Europe, the number of people dying was greater per thousand. We normalized it to that. Over here on the left, you'll see that Finland, USA for that matter, don't have as much problem. The interesting thing about this is we're not thinking of the ice not being safe. If you are an ice fisherman, or if you watch the ice fishers in our lakes here in the Madison area, the fishermen at least have a spud with them, and they can break the ice and see whether it's this type, and the paper keeps publishing when it's safe. But another thing that's happening is the quality of the ice is changing, so it's not as strong. And so we expect that some of these lakes that are on the left-hand side are going to start moving out here. So where we began. Compliments on dealing with minutes, days and nights and seasons, beginning to address eutrophication and land use. But we haven't begun to address the climate issue in a very real way. And it's one of the things that's happening slowly. But if you take records where we have 80 years or 40 years or 160 years, you're beginning to see slow changes that you could not see because most of us live in the invisible present. And some winters were lucky enough to get this ice ridges that form. I didn't talk about Sewell, but they had a legend for Lake Sewell in the Shinto church that when these would form, it meant that the male god would be walking across the lake to visit the female god at a shrine on the other side of the lake. And these were pushed up by, well, we now know that's not what happens. And if you want to know about the physics of this, I'll explain it. But for me, it's a nice photograph because it represents what's happening with our ice table. It's highly variable and it's changing. So be aware and use what we learned today to help understand long-term change. Do not fall victims to living in the invisible present and the invisible place. And here are my grandkids.